Figure 9.2 shows a piece of sodium being held under water. Okay, so they're going to collect some gas. Name the type of gas. Well, metal plus water, alkali metals. This would make sodium hydroxide in the solution and hydrogen gas is released. How would you know this? Well, you can collect the gas with displacement here, and then what you do called the lighted splint test, and that should give you a nice squeaky pop. So you take a splint, you light it, and then ignite the gas. The pH of the mixture in the water contained increases during the reaction. Explain why this is. As we mentioned, sodium hydroxide is produced, and that's going to be alkaline. Solid L is a mixture of two compounds. So a student dissolves sample L into some distilled water and then carries out some tests to identify one of the cations and both anions. Okay, so the cation, if you remember, we've got anions which are negative and cations which are going to be positive. All right. So what happens first? Explain why it is important to use distilled water to make a solution. Well, if you're adding extra ions in, you might get a false positive. So if I add some copper ions or chloride, so small amounts of salt that are in the solution, then you're going to get potentially a positive test where you shouldn't have had one. So distilled water or deionized water means there's no other ions affecting your result. Okay. So just a conclusion which can be made from observation of test 1. Well, if you had ammonia solution and you get a dark blue solution, yeah, this happens when you do with copper ions, if you had an excess of ammonia solution. Okay, the next question talks about this. It says another student did it and their observation is a blue precipitate. It's usually a light blue precipitate. So if you had a limited amount of ammonia, you get a light blue precipitate. If you then add even more, it redissolves and forms this deep blue solution. Okay, if you actually do this with sodium hydroxide, you'll only get the light blue precipitate. You don't get this special one with the nitrogen on. Okay, and actually it's the same test that you end up using for testing for proteins. Okay, but that's for something else. So the idea is we should have copper ions, Cu2+. The student did not include how they identified the bubbles of gas as carbon dioxide in test 2. Okay, so how should they do this? This is easy enough. Bubble it through lime water, which then goes cloudy or milky, and just remember that the lime water really is calcium hydroxide. Don't forget in OH bracket 2 because OH is single minus and calcium is 2+. Draw a label diagram of the apparatus used to test it. What's the important bit? Well, you've got your reaction, so I have L plus HCl. L was that solution that I had, and when it reacts and produces bubbles, obviously the delivery tube needs to come around and it needs to then go through the lime water, so it needs to be underneath and hopefully turn it kind of cloudy. Okay, so you need to kind of connect it right and label it with delivery tube and lime water. The instructions for test 3 in table 2.1 are incorrect for the test for sulfate ions. Why was it? Well, if we just sort of skip back, you'll notice they used barium nitrate, which is correct. So barium nitrate, barium sulfate will work. It's the barium ion doing the work. But then they added sulfuric acid. So sulfuric acid, the idea is you add an acid to see if whether there's a carbonate present. If you add any acid, it starts to fizz, you know you've got a carbonate. So you add the acid, did it fizz? Hopefully not, it didn't say anything. Okay, which means then you go, therefore I'm going to now go ahead and test it for sulfates. But by doing so, you've already added sulfate ions when you added the sulfuric acid. So you're going to then create a positive test. So thinking you've got sulfate ions when perhaps you haven't. Okay, so you need to use a different type of acid. You still need to check for your carbonates, okay, but not with sulfate ions. So you'd probably use nitric acid to use nitrate ions, or hydrochloric acid would give you chloride ions, but either one wouldn't give you that positive test with the barium. Okay. When the student repeats test 3, no precipitate is formed. He then carries out, so basically saying he didn't get a positive test for the sulfate, so it was in fact an incorrect test. So then he carries out the test to confirm the presence of chloride ions. So how would he do that? Well, just like last time, you add an acid, first of all, to check to see if it's a carbonate. So he did that, presumably it didn't fizz, yeah, because he got a positive test for chloride, which means it doesn't fizz, but then you add silver nitrate, and that silver nitrate will end up forming silver chloride, which actually gives you a white precipitate, okay, which is the positive test for chloride ions, and but it's only asking for the chemicals, okay.